Unsupervised classification. For this exercise, we will use Landsat 9, 7 spectral bands, reflectance dataset and 5 ROIs representing vegetation, crops, urban areas, snow, water and forest. Unsupervised classification is a fundamental image processing technique used in remote sensing to automatically group pixels into distinct classes based on their spectral properties. Unlike supervised classification, which requires predefined training data, unsupervised classification algorithms analyze the inherent patterns within an image and cluster similar pixel values together without prior knowledge of the land cover types. This approach is particularly useful when working with large datasets or in areas where little ground truth information is available. Common algorithms, such as K-Means and Isodata, iteratively assign pixels to clusters based on spectral similarity, refining class definitions through multiple iterations. Unsupervised classification is widely applied in land cover mapping, environmental monitoring, and change detection. It allows researchers to explore data-driven patterns in satellite imagery, making it an essential tool for preliminary analysis before more detailed classifications or for identifying unknown features within a scene. Isodata classification. Isodata unsupervised classification calculates class means evenly distributed in the data space, then iteratively clusters the remaining pixels using minimum distance techniques. Each iteration recalculates means and reclassifies pixels with respect to the new means. Iterative class splitting, merging, and deleting is done based on input threshold parameters. All pixels are classified to the nearest class unless a standard deviation or distance threshold is specified, in which case some pixels may be unclassified if they do not meet the selected criteria. This process continues until the number of pixels in each class changes by less than the selected pixel change threshold or the maximum number of iterations is reached. From the toolbox, select Classification, Unsupervised Classification, Isodata Classification. Isodata classification dialog appears. Select an input raster and perform optional spatial and spectral subsetting. Optional, enter the number of classes to define. The default value is 5. Optional, enter a change threshold %, which will determine when to complete the classification. When the percentage of pixels that change classes during an iteration is less than the threshold value, the classification completes. The default value is 2%. Optional, enter the maximum number of iterations. If the change threshold % is not met before the maximum number of iterations is reached, the classification completes. The default value is 10. Specify a file name and location for the output raster. Enable the preview checkbox to see a preview of the settings before you click OK to process the data. The preview is calculated only on the area in the view and uses the resolution level at which you are viewing the image. See preview for details on the results. To preview a different area in your image, pan and zoom to the area of interest and re-enable the preview option. Enable the display result checkbox to display the output in the view when processing is complete. Otherwise, if the checkbox is disabled, the result can be loaded from the data manager. To reuse these task settings in future Envi sessions, save them to a file. Click the down arrow and select Save Parameter Values, then specify the location and file name to save to. Note that some parameter types, such as rasters, vectors, and ROIs, will not be saved with the file. To apply the saved task settings, click the down arrow and select Restore Parameter Values, then select the file where you previously stored your settings. To run the process in the background, click the down arrow and select Run Task in the background. If an Envi server has been set up on the network, the Run Task on Remote Envi server name is also available. The Envi server job console will show the progress of the job and will provide a link to display the result when processing is complete. See Envi servers for more information. Click OK. K-Means. K-Means unsupervised classification calculates initial class means evenly distributed in the data space, then iteratively clusters the pixels into the nearest class using a minimum distance technique. Each iteration recalculates class means and reclassifies pixels with respect to the new means. All pixels are classified to the nearest class unless a standard deviation or distance threshold is specified, in which case some pixels may be unclassified if they do not meet the selected criteria. This process continues until the number of pixels in each class changes by less than the selected pixel change threshold or the maximum number of iterations is reached. From the toolbox, select Classification, Unsupervised Classification, K-Means Classification. The Classification Input File dialog appears. Select an input file and perform optional spatial and spectral subsetting, and/or masking, then click OK. The K-Means Parameters dialog appears. Enter the number of classes and maximum number of iterations in the fields provided. Enter a change threshold %0 to 100%, which Envi uses to end the iterative process when the number of pixels in each class changes by less than the threshold. The classification ends when either this threshold is met or the maximum number of iterations is reached. To set the optional standard deviation to use around the class mean and/or the maximum allowable distance error, in DN, enter the values in the maximum SDEV from mean or maximum distance error fields, respectively. If you enter values for both of these optional parameters, the classification uses the smaller of the two to determine which pixels to classified. If you do not enter a value for either parameter, then all pixels are classified. Select Output to File or Memory. Click OK. The status bar cycles from 0 to 100% for each iteration of the classifier. Envi adds the resulting output to the Layer Manager. Envi computes the statistics for the initial class seeds with a skip factor of 2.5 for both the sample and line directions.